Good morning, students. In yesterday's class, we introduced the Michaelis method, how to integrate the curvature equation according to the Michaelis method. We know that while integration, the whole bracket term is assumed as a single term, and the constants of integrations applicable for whole section of the beam. And now, some other problems which are solved by Michaelis method. Let us come to the example 8, which is a cantilever with UVL. Determine the slope and deflections at the free end of the given cantilever beam when it is loaded, as shown in figure. This is the cantilever beam with UVL having maximum load intensity at the fixed end and 0 is at free end. Okay, this is the load, which is load intensity maximum at fixed end and 0 at free end. This is a UVL having the length L. Okay, this represents the concentration load which are having a left hand side of the section, which is at a distance of height by 3. Let us take the XX section at a distance of x from the fixed end. Okay, students. After taking the section XX, we have to find the bending moment at XX. What is the bending moment XX? Before finding the bending moment at XX, what is the load intensity at this section? What is the load intensity? How to find the load intensity at this section? By taking the similar triangles. This is the one of the triangle and this is the one of the triangle. These two are the similar triangles. By similar triangle principle, we can find the load intensity at XX section. This is the load intensity at XX section, W into L minus X by L. How to find that? Let us take this as Y. Y by W. This is the load intensities at two different triangles. Load intensities, that is Y by W. Y, this is the height of the smaller triangle divided by the height of the bigger triangle, is equal to length of the smaller triangle divided by length of the bigger triangle. What is the length of the smaller triangle? It is L minus X. What is the length of the bigger triangle? Is capital L. So from this Y equal to W into L minus X by L. This is the load intensity at XX section. After finding the load intensity at XX, bending moment. What is the bending moment equation at XX? Bending moment at XX is M. So M, what is the M? Bending moment at XX. How to find the bending moment at XX? Bending moment means the moment of all the forces on the right side of the section. What is the bending forces which are acting on the right side of the section? This is the force. This is the UVL which is acting on the right side of the section. Okay, so how to find the load intensity? Load at the right side is the area of the triangle which is right side of the section. Area of the triangle is half into length. What is the length of the smaller triangle? That is L minus X into what is the height? W into L minus X by L. Load intensity is W into L minus X by L height. So this is the total load acting on the right side of the section. Okay, this is a arrow mark indicates this load which is concentrated at center of gravity. This point is center of gravity. So center of gravity which is located at a distance of L minus X by 3 from the XX section. This is the total length is L minus X on the right side center of gravity of the load intensity at a distance of height by 3, L minus x by 3 from the base. Base is XX section. So load is load intensity into L minus x by 3, then we can get the movement about XX. Load into distance, perpendicular distance. This is the M equal to half into W into L minus x by L into L minus x is the load intensity into L minus x by 3 is the distance. The minus sign represents, what is the minus sign? Minus sign represents clockwise movement about XX section. Therefore, M equal to minus W by 6L into L minus x into L minus x into L minus x whole cube. So in double integration method, we have to elaborate this L minus x whole cube. Already we solved this problem by double integration method. By elaborating means a minus b whole cube formula ఉంది, then elaborate చేసి మనం integrate చేస్తాం. But in Michaelis method, according to Michaelis method, we need not elaborate this bracket term. Directly we can integrate this bracket term as assumed as single term. Okay, from the curvature equation, EI d square y by dx square is equal to minus m. This is the curvature equation. After substitution of bending moment equation in curvature equation, EI d square y by dx square is equal to W into L minus x whole cube by 6L. Minus minus cancel, that is a plus. So by integrating the above equation, how to integrate this? According to the Michaelis method, if we integrate this, on the left hand side we will get EI dy by dx. EI is the constant, d square y by dx square integration is dy by dx is equal to W by 6L, L minus x whole cube integration minus L minus x whole power 4 by 4. So minus x is there, that's why we are taking minus sign in front of this expression. Plus C1 is the integration constant. So it is x cube formula only, x cube integration x power 4 by 4. That's why L minus x whole power 4 by 4. If minus x is there, the minus sign should be put in front of the expression. That is the integration of the above expression according to the Michaelis method. Then by integrating once again in the above equation, we integrate this equation once again. Integrate this equation once again, we will get on the left hand side EI y is equal to W by 6L. Isn't it? L minus x whole power 4 is there. L minus x whole power 4 integration L minus x whole power 5 by 5. Minus x is there. So if we put the minus on in front of the expression, minus minus plus again. So W by 6L, L minus x whole power 5 by 5 into 4 is 20. Plus C1x plus C2. Okay, if we integrate this term, L minus x whole power 4 integration, L minus x whole power 5 by 5. So already in the denominator 4 is there, and 5 into 4 is 20. The minus sign will be cancelled due to, again, minus 1 will become after integration. Minus minus plus. Minus into minus plus. So after 2 times integration, we will get the deflection equation. Isn't it, students? Or you get it? Okay. These are the 2 expressions to calculate the slope and deflections, including C1, C2 or the integration constants. How to eliminate these? How to replace the C1, C2 values? By using boundary conditions for the given beam. So C1, C2 are the integration constants which can be determined the following boundary conditions. What are the boundary conditions for cantilever beam? For cantilever beam, at fixed end, the slope and deflections are 0. Isn't it? Slope and deflections both are 0. So at x is equal to 0, that means at fixed end, slope is 0. At x is equal to 0, that means at fixed end, deflection also 0. So both are 0, slope and deflections both are 0 at fixed end. X is equal to 0 means at fixed end. So from the boundary condition 1, if we substitute this boundary condition into our slope equation, then we will get, what is the slope equation? This is EI dy by dx is equal to minus 6L minus W by 6L into L minus x whole power 4 by 4 plus C1. If you substitute in place of dy by dx 0, left hand side 0, in place of x 0, therefore L minus 0 whole power 4. So minus W by 6L, L minus 0 whole power 4 by 4 plus C1. Left hand side is 0, dy by dx value 0. So from this, L minus 0 whole power 4 by means L power 4 by 4. So L power 4 in the numerator, L is in the denominator, then L cube remains in the numerator. So minus W L cube by 6 into 4 is 24 plus C1. So from this expression, C1 equal to WL cube by 24. It will be goes on another side. It becomes positive. So C1 is equal to WL cube by 24. Dear students, you get my point? Okay, from the boundary condition 2, how to get the boundary condition 2? At x is equal to 0, y 0. From this boundary condition, if you substitute this boundary condition into our deflection equation, what is the deflection equation? We have EIY equal to W by 6L into L minus x whole power 5 by 20 plus C1x plus C2 is there. So from this deflection equation, if you substitute x is equal to 0, then y is equal to 0, deflection 0. So left hand side 0 value, it becomes 0. W by 6L, L minus 0 whole power 4 or 5 by 20, C1 into 0, 0 is 0 plus C2. So L minus 0 whole power 5 by 20 plus 0 plus C2. So from this we can get the C2, another integration constant. C2 value WL power 4 by 120. Okay. Therefore, C2 is equal to minus WL power 4 by 120. It will go to another side, then it will becomes minus sign. Okay, students. These are the C1, C2 values. After getting C1, C2 values, you can write the final slope and deflection equations. So final slope and deflections equation, after rewriting the C1, C2 values, after substituting the C1, C2 values, slope equation is EI dy by dx is equal to minus W by 6L into L minus x whole power 4 by 4 plus WL cube by 24 is the C1 value. WL cube by 24 is the C1 value. And slope deflection equation is EI y equal to W by 6L L minus x power 5 by 20 plus WL cube by 24 is the C1x, WL cube by 24x minus C2 value minus WL power 4 by 120. So minus WL power 4 by 120. These are the slope and deflection equations after substituting the C1, C2 values. So these are the equations which are very useful to find the slope and deflections at each point of the beam. So in this problem, we are going to find the slope and deflections at the free end. Free end means that x is equal to length of the beam, that is x is equal to L. After substitution of x is equal to L into these equations, then we can get the slope and deflections at the free end. So if you substitute in place of x, L value in the slope equation, so L minus L is 0. This term is 0. Then slope EI dy by dx at point B is equal to WL cube by 24. Similarly, if you substitute in place of x, L value, L minus L is this term is 0. This term WL cube by 24 into L, WL power 4 by 24 minus WL power 4 by 120. That is equal to EI YB. YB means the deflection at point B. If you substitute in place of X, L value, then we'll get the deflection at point B. So after getting slope at the free end of the beam, that is at X is equal to L, EI theta B, theta is the slope or dy by dx is also slope. Theta B is the slope at point B, free end is equal to minus 6W by 6L, L minus L all power 4 by 4 plus WL cube by 24. This term is 0, then WL cube by 24. Theta B equal to WL cube by 24 EI. This is the formula to calculate the slope at free end for the UVL load. Similarly, deflection at the free end. Similarly, deflection at the free end is equal to X is equal to L. So after substitution of X plus L in deflection equation, we'll get EI YB. YB is the deflection at the free end. If you write YB in place of Y, you must substitute in place of X L value. So W by 6L, L minus L all power 5 by 20 plus WL cube by 24 into L minus WL power 4 by 120. This equation comes from the deflection equation. So this first parameter is 0. WL power 4 24 minus WL power 4 by 120. From this 120 is LCM. 5 WL power 4 minus WL power 4 is the 4 WL power 4 by 120. 4 by 120 is 30. So WL power 4 by 30. So finally we will get the deflection at the free end. YB equal to WL power 4 by 30 EI. This is the formula to calculate the deflection at the free end if the UVL is acting on the cantilever. Clear, students? Like this, any problem we can solve by the Michaelis method. So this procedure is same for all the problems. Let us go for another problem, example 9. Find the slope and deflection under the load of 20 kilonewtons. So here, point load is acting on the SSB. Point load is acting on the SSB, simply supported beam. But it is not acting at the center. It is somewhere else at a distance of 3 meters from the left support. The total span of the beam is 5 meters. Find the slope and deflection under the load of 20 kilonewtons acting at a distance of 3 meters from the left support of a simply supported beam of span 5 meters. Take EI, flexural rigidity value 10 to the power of 7 Newton meter square. Also find the maximum deflection and its position. So we have to find the slope and deflection under the load and also maximum deflection in the beam and its position, where the maximum deflection occurs. So given data is W equal to 20 kilonewtons point load which is acting at a distance of 3 meters. L is equal to 5 meters. EI is the 10 to the power of 7 Newton meter square. After conversion it into kilonewton meter square, 10 to the power of 4 kilonewton meter square. We have to find the slope at point C, that is under the load. YC, deflection at point C, that is to a deflection under the load. And Y maximum deflection somewhere else occurs in the beam. Okay, students. Let us go to the solution. Consider a XX section. Again, consider an XX section at a distance of X from the left support. ఈ left support నుండి XX section consider చేస్తాం. So after considering the XX, you have to write the bending moment at XX. Let us take the bending moment at XX is M. Before finding the bending moment, we have to know the reaction forces RA, RB. So to find the reaction forces by taking the equilibrium equations, that is sigma Fy equal to 0. Sigma Fy equal to 0 means all the upward forces must be equal to all the downward forces. So all the all the upward forces are Ra plus Rb. The downward force is one force is there, that is the load value 20 kilonewtons. So Ra plus Rb equal to 20. Then by taking the moment at point A, sigma Ma equal to 0. Take the moment at point A and equate to 0. So if we take the moment at A, Rb into phi, it is in anti-clockwise direction positive, and minus 20 into 3, it is clockwise minus 20 into 3. So Rb into phi minus 20 into 3 equal to 0. So Rb into phi equal to 20 into 3. From this, Rb is equal to 5 4 is 4 3 is 12. So Rb is equal to 12 kilonewtons. After substitution of Rb value in equation 1, Ra is equal to 8 because both summation of these two is 20. So Ra is 20 kilonewtons. These are the reaction forces at supports, Ra, Rb values. So after getting the reaction forces, we can write the bending moment at xx. So how to write the bending moment at xx? Bending moment at xx means the summation of algebraic summation of all the moments on the right side of the section. Bending moment means the moment of all the forces on the right side of the section. So what are the right side forces? Rb is there and 20 kilonewtons also there. So Rb is acting at a distance of 5 minus x. 20 is acting at a distance of, this is 3 meters, this is the x, therefore the distance between force and section is 3 minus x. Clear, students? Let us write the bending moment equation. Bending moment equation is m equal to 12. 12 is the Rb value. 12 into 5 minus x, which is in anti-clockwise direction positive, minus 20 into 3 minus x, it is a clockwise movement. That's why I'm taking the minus sign here. So 20 into 3 minus x, 12 into 5 minus x. So from the curvature equation, ei d square y by dx square is equal to minus m. So after substitution of m into a curvature equation, ei d square y by dx square is equal to minus m is there here, m equation is there. So minus 12 into 5 minus x plus minus into minus plus 20 into 3 minus x. This is the after substitution in the curvature equation. So by integrating the above equation according to Michaelis method, if we integrate this equation, we will get ei dy by dx is equal to, if we integrate this term, minus 12 is there, 5 minus x integration, 5 minus x whole square by 2, minus 5 minus x whole square by 2. So minus minus plus by 2, 12 by 2 is 6, 6 into 5 minus x whole square. So here 20 is there, 20 into 3 minus x, 3 minus x whole square by 2 is the integration, minus 3 minus x whole square by 2. So minus into plus minus 3 minus x whole square by 2 is 20 by 2 is 10. So minus 10 into 3 minus x whole square by 2. So I will write again this equation. If we integrate the first term, minus 12 is there. So 5 minus x integration, 5 minus x whole square by 2. So minus x is there, minus minus plus. So 12 by 2 is 6. So I am written here 6 into 5 minus x whole square. Similarly, integration of 20 into 3 minus x. So 20 is the constant and 3 minus x integration minus 3 minus x whole square by 2. So 3 minus x whole square by 2, minus x is there, so minus sign must be put in front of the expression. So 2 tens are. That's why I'm writing here minus 10 3 minus x whole square plus c1x is c1 is the constant, integration constant. Clear, students? After integration, once again we will get on left hand side ei is equal to, so integration of 5 minus x whole square. What is the integration of 5 minus x whole square? 5 minus x whole cube by 3 minus I. So every time you have to remember that during integration, this whole bracket term is as a single term, and while integration minus x, if minus x is there, minus sign must be put in front of the expression. So minus 6 is there initially, 5 minus x whole cube, 6 by 3 is 2. 5 minus x whole cube. Here plus again it becomes plus 10 into 3 minus x whole square integration 3 minus x whole cube by 3 minus expression minus plus it becomes plus. So 10 into 3 minus x whole cube by 3 plus c1x plus c2. c1 is the constant, which is constant integration c1x plus c2. c2 is the second integration constant. Dear students, these are the two expressions including c1, c2 values represent slope and deflection expressions. So c1, c2 are the integration constants which can be determined by the following boundary conditions. Again, by substitution of boundary conditions, we can get c1, c2 values. So first boundary condition is at x is equal to 0. At x is equal to 0 means here we are taking x from the left support. So if x is equal to 0, the position of the section is A. So at x is equal to 0, what is which parameter is 0? The beam is not deflecting at point A. So deflection is 0 at this x is equal to 0. Okay. If x is equal to 5 meters, x is equal to 5 meters means at this support. So at this support also deflection 0. So these are the two boundary conditions we have to take. So at x is equal to 0, y 0, deflection 0. At x is equal to 5 meters also deflection 0. These are the two expressions to find the constants of integration c1, c2 values. So from the boundary condition 1, from the first boundary condition, after substitution of first boundary condition into deflection equation. So left hand side is 0 because y 0. Right hand side minus 2 into 5 minus 0 whole cube, x plus 0, plus 10 into 3 minus 0 whole cube by 3, plus c1 is 0, c1 into 0 is 0, plus c2. So from this expression, we will get the c2 value as 160. Okay, after calculating 5 minus 0 whole cube means 5 cube, 125 into 2 minus 150, 3 minus 0 whole cube means 3 cube, 3 cube by 3 is 3 square, so 3 square is 9 into 10, 90. So 90 minus 250 is minus 160. If we get another side of the equal, so C2 equal to 160. Clear students? So after substitution of first boundary condition, C2 value 160. Next, by substituting the second boundary condition into our equation, what is second boundary condition? At x is equal to 5 meters, y 0. So y 0 means on the left hand side expression 0. That is equal to, if you substitute in place of x 5, minus 2 into 5 minus 5 whole cube. Okay. So during substitution of x value, if the bracket term is negative value, then the total term can be neglected. This is one of the rule in Michaelis method. So after, if you substitute 5 value in place of x, 3 minus 5 is the negative value, 3 minus 5 is minus 2, that is negative value. If bracket term is negative, if this term, whole term can be neglected, and this term is 0. Bracket term negative vaste total term ni manam neglect cheyochu, manam teeskokuda aa term ni. So next term is c1 into 5 c1 plus c2. So I written here only we have 5 minus 5 is 0. This term is also neglected term. This total, these two terms can be neglected. So c1 into 5 plus c2 is equal to 0. c2 value is 160. So 5c1 plus 160 is equal to 0. From the second boundary condition, c1 value is minus 32. So after substitution of c1, c2 values into our slope and deflection equations, then we will get the final slope and deflection equations. EI dy by dx is equal to 6 into 5 minus x whole square minus 10 into 3 minus x whole square minus 32 is the slope equation. Already we derived this equation. C1 is replacing with minus 32. So minus 32 is there. And deflection is also deflection equation minus 2 into 5 minus x whole cube plus 10 into 3 minus x whole cube by 3 minus 32x. C1 x is there in the deflection equation. C1 value is minus 32. So minus 32x plus C2 value is 160. After getting the slope and deflection equations, we can calculate the slope and deflection under the load. In this problem, we have to find the slope and deflection under the load, isn't it? Find the slope and deflection under the load 20 kilonewtons. So under the load means at this point. At this point, what is the slope and deflection of the curve after deflecting? So how to find the slope and deflection? By substitution of x value 3 meters. Because at this point, x value is 3 meters. So if you substitute x is equal to 3 in the slope equation, we will get the slope under the load. And if you substitute the 3 meters in place of x in deflection equation, we will get that vertical displacement of this beam at point C. Okay, this is the deflection. From this place to this place is the vertical displacement. It is the deflection under the load YC. And if you draw the tangent at that point, if you draw the tangent at that point, it makes an angle with initial position is called the slope at that point. So theta C. These two must be calculated in this problem. Slope and deflection under the load means theta C and YC. What is the slope and the deflection at point C? So after substitution of 3 meters in place of x in slope equation, this is the slope equation. EI in place of dy by dx I was written theta value. At C means the slope at point C, EI theta C is equal to 6 into 5 minus 3. In place of x, we have to substitute 3 meters, 5 minus 3 whole square, minus 10 into 3 minus 3 whole square, minus 32. So 3 minus 3 is 0. This term will become 0. So after calculating 5 minus 3 is 2, 2 square is the 4, 4 into 6, 24, 24 minus 32 is minus 8. So EI theta C is equal to minus 8. Theta C is equal to minus 8 by EI. Minus 8 by EI value is 10 to the power 4 given in the problem. So minus 8 into 10 to the power minus 4 radians. This negative term represents a counterclockwise or anti-clockwise slope. I already drawn the slope curve. If you draw the tangent at this point, point C, after deflection, the slope line, that is the tangent line, makes an angle anti-clockwise slope with respect to initial position. Okay, this is the anti-clockwise direction. If you draw this tangent at this place, this is the clockwise direction. So it is positive slope. At point C, it will become negative slope. That's why the minus sign came. That minus sign indicates the negative slope occurs at point C. So minus 8 into 10 to the power minus 4 radians. Theta comes into radians. So after conversion radians into degrees, we will get minus 0.045. How to convert this 8 into 10 to the power minus 4 into degrees? 8 into 10 to the power minus 4 into 180 by pi, then we'll get the degrees. Minus 0.045 degrees, which is counterclockwise slope or anti-clockwise slope. Okay, that negative sign represents anti-clockwise slope. If you get at the positive slope, then that is the clockwise slope. So deflection under the load, again we have to substitute x is equal to 3 meters into deflection equation. So EI YC, you have to write in place of YC. Whenever you write the YC, you have to substitute x place low 3 meters substitute cheyali. So EI YC is equal to minus 2 into 5 minus 3 whole cube plus 10 into 3 minus 3 whole cube by 3 minus 32 into 3 plus 160. So this term also 0, 3 minus 3 0, 5 minus 3 is the 2, 2 cube 8, 8 into 2 minus 16. Minus 16 plus 60 plus 160 minus 32 into 3, we will get the 48 final value. So EI YC equal to 48, YC is equal to 48 by EI, that is equal to 48 divided by 10 to the power of 4, that is equal to 4.8 into 10 to the power of minus 3 meters. We will get the deflection in units or meters. So after conversion to the millimeters, 4.8 into 10 to the power minus 3 into 1000. So 1000 into 10 to the power minus 3 cancel. We will get the YC value is 4.8 mm. It is positive. We will get positive. Therefore, positive represents downward deflection. Downward deflection is positive. Upward deflection is negative. Clockwise slope is positive. Anti-clockwise slope is negative. Okay. Here minus sign came in the slope equation. That negative sign is counterclockwise direction. Your positive value is there in the deflection equation. Therefore, positive sign represents downward deflection. These are the slope and deflections under the load at point C. Then how to get the maximum slope, maximum deflection? Maximum deflection will get wherever the maximum deflection. Once again, I will go for the diagram. So maximum deflection occurs somewhere else. Here the maximum deflection occurs. Wherever the maximum deflection occurs, the slope at that point is 0. If you draw the tangent at that maximum deflection point, you will get the horizontal tangent. Horizontal tangent makes an angle 0 with horizontal position. Therefore, wherever the maximum deflection occurs at that point, slope is 0. If you put the slope value 0, we will get the distance at which the slope is 0. How to get the that value? If you put the 0 value in place of dy by dx, we know that slope equation is EI dy by dx is equal to 6 into 5 minus x whole square minus 10 into 3 minus x whole square minus 32. If you put the dy by dx value 0, we will get the x value where the slope is 0. So left hand side is 0. After putting the dy by dx, maximum deflection occurs in the beam where the slope is 0, theta 0. So therefore 0 equal to 6 into 5 minus x whole square minus 10 into 3 minus x whole square minus 32 is the slope equation. So after elaborating these terms, 6 into 5 minus x whole square is 25 plus x square minus 10x, a minus b whole square form, minus 10 into 3 minus x whole square, elaborate this term. After elaborating 9 plus x square minus 6x minus 32. So after getting, we will minus 4x square plus 28 is equal to 0. Okay. Minus 60x plus 60x cancel. Minus 10x square plus 6x square is minus 4x square. 150 minus 90, 40 minus 32 is 28. 150 minus 90, 60 minus 32 is 28. So x value we will get 2.645 meters. This x value, what it represents? This represents the position of the maximum deflection. So position of the maximum deflection where the slope is 0 is 2.645 meters. So by substituting this x value into the deflection equation, then we will get the maximum deflection. At x is equal to 2.465. ఇక్కడ నుండి 3.465. 2.645. 2.645 meter distance లో అంటే ఇది 3 meters ఇక్కడ వరకు అంటే బిఫోర్ దిస్ 2.645 meter distance లో స్లోప్ 0 అవుతుంది. సో స్లోప్ 0 అయిన చోట మాక్సిమం డిఫ్లెక్షన్ అక్కడ అవుతుంది. సో మాక్సిమం డిఫ్లెక్షన్ కావాలి అంటే డిఫ్లెక్షన్ ఈక్వేషన్ లో మనకి వచ్చిన 2.645 డిస్టెన్స్ సబ్స్టిట్యూట్ చేస్తే అక్కడ మాక్సిమం డిఫ్లెక్షన్ వచ్చేస్తుంది. సో EI Y max is equal to మనం ఎందులో సబ్స్టిట్యూట్ చేయాలి? ఈ డిఫ్లెక్షన్ ఈక్వేషన్ లో x ప్లేస్ లో 2.645 meters సబ్స్టిట్యూట్ చేయాలి. సబ్స్టిట్యూట్ చేస్తే we will get Y max. So EI Y max is equal to minus 2 into 5 minus 2.645 whole cube plus 10 into 3 minus 2.645 whole cube by 3 minus 32 into 2.645 plus 160. అంటే ఏం లేదు, ఎక్స్ ప్లేస్ లో 2.645 సబ్స్టిట్యూట్ చేశాను, లెఫ్ట్ హ్యాండ్ సైడ్ లో y ప్లేస్ లో y మాక్సిమం రాసుకున్నాను. సో ఆఫ్టర్ క్యాలిక్యులేటింగ్ దిస్ expression, we will get the 49.38 on the right side. So Y max can be write as 49.38 divided by EI. EI value 10 to the power of 4 given in the problem. Therefore, we will get the 4.938 into 10 to the power minus 3 meters. Clear, students? So after conversion into the millimeter, 4.938 mm. This is the downward deflection. Because how to say this downward deflection? We got the positive value. Deflection is positive value. So if we get the positive value, that is, it represents downward deflection. So beam downward deflects downwards at a distance of 2.645 meters is 4.938 millimeters. Okay, students, this is the maximum deflection in the beam. Already we find the deflection at the point C, 4.8 mm, but maximum deflection in the beam is 4.938 mm at a distance of 2.645 meters from the left support. So, ఈ విధంగా మీరు maximum deflection find చేయడానికి first slope 0 చేసుకోవాలి, x value find చేసుకోవాలి, x వచ్చిన తర్వాత deflection equation లో substitute చేసుకుంటే మనకి maximum deflection value వస్తుంది. Clear, students? This is the problem. Simply supported beam with point load. Clear, students? This is the curve which represents after deflection. ఈ curve ఏంటంటే beam deflect అయిన తర్వాత పొజిషన్. ఇక్కడ deflections 0. Maximum deflection ఇక్కడ occur అవుతుంది 2.645 meters లో occur అవుతుంది. Deflection at point C మనం find చేసుకున్నాం. Slope కూడా negative slope వచ్చింది. అంటే ఇక్కడ మనం slope tangent draw చేస్తే it makes angle negative angle with respect to initial position. అంటే maximum deflection నుండి left hand side లో positive slope ఉంటుంది. Maximum deflection నుండి point నుండి right hand side లో negative slope ఉంటుంది. Okay na? Let us go for next problem. You solve this problem as a homework. You take this problem as homework. Okay? Example 10 is as homework. It is a cantilever again, acting 2-point loads. Find the deflection under the loads of the cantilever beam as shown in figure. E point దగ్గర deflections find చేయండి. YC, YB find చేయండి. Okay? ఇక్కడ ఇచ్చిన answers you have to compare your answer with given answer. YC, the deflection at point C is 14 mm. Deflection at point B, free end is 49 mm. Flexural rigidity value here is given as 10 to the power 4 kilonewton meter square. So this is a given problem. By taking the XX section at a distance of x from the fixed end, write down the bending moment equation at XX. Bending moment equation with the moment algebraic summation of all the moments of the force on the right side of the section. That is 10 kilonewton, 20 kilonewtons is there. Write down the bending moment equation at XX. Substitute in that curvature equation and integrate 2 times. And substitute the 2 boundary conditions in the slope and deflection equations. After getting C1, C2 values, write the final slope and deflection equations. And by substitution of x place 2 meters, in place of x 2 meters, we will get the deflection at C. And if you substitute in place of x 5 meters, we will get the deflection at point B. Clear, students? Try this problem and compare your answers with this given answer. This is taken as homework. Take it as homework. Let us close this class at this point. We will discuss next problems, some more problems in the next class. Okay? Bye, students. Have a nice day.